I want to sketch a graph of a function that satisfies the given conditions. So the way I'm going to do this is draw out a number line, first derivative and second derivative. And then I'm going to use these facts here. So the derivative is less than 0 between negative infinity and negative 2. That means it's decreasing. From negative 2 to 1, it's positive, so that means it's increasing. And then from 1 to 6, it's decreasing. 6 to 9, the derivative is positive, that means it's increasing. And then 9 to infinity, the derivative is negative, so that means it's decreasing. Okay, so these conditions are met. Now for the second derivative, I want to line up the numbers with the first derivative. So the first one we're given is negative infinity to 0. So negative 2 is over here, 1 is here. I'm going to put 0 kind of close to 1. And there the second derivative is positive, that means it's concave up. Next, from 0 to 6, the second derivative is negative, and that means it's concave down. And it's also concave down from 6 to 12. And from 12 to infinity, it's positive, so it's concave up. So I was able to take care of all these 4 conditions. And now I just need to look at what we're given. So I'm going to first start off with the derivatives. The derivative of negative 2, 1, and 9 is 0. So I'm going to circle them. And this makes sense because you see here it changes from decreasing to increasing. This is a minimum, so the derivative is 0. At 1, it changes from increasing to decreasing. That means it's a maximum, so the derivative is 0. Same thing with x equals 9. This is a maximum, so the derivative is 0. Okay, this makes sense. We just need to make sure that f of 0 is equal to 0. The limit as x approaches infinity is 0. And then the limit as x approaches 6 equals negative infinity. So it actually turns out here that it's going to be an asymptote, because at x equals 6 here, you always want to look at where your function is, the derivative is undefined or 0 for the first derivative test, to find the critical points. So at 6, it's going to be an asymptote. And yeah, now we can start graphing. Okay. So the nice thing is I pretty much could use my table here with a few of the other conditions. So we said f of 0 is 0. That was one of the conditions. And we said that 6 is an asymptote because it goes to negative infinity. And let me see what else we need that's not in this table. We need the limits. So the limit, I guess I could just write on the side here. Limit as x approaches infinity, f of x is 0. Limit as x approaches infinity, x approaches 6, of f of x is equal to negative infinity. Okay, now we're good to go. So I have everything that I need here to graph. So the nice thing about this is I could just start from left to right. Okay, so from, let's say, negative infinity, I'm going to be decreasing and concave up. Okay, up until I hit negative 2. Negative 2 is a minimum. So I'm decreasing and I'm concave up. So let's say at negative 2, it's over here somewhere. Okay, the next point I'm going to hit is 0. So you just go in order. Negative 2, now you go to 0. At 0, you're still concave up, but you're going to be increasing. Concave up, increasing, and you have to connect it at the point at x equals 0. So you have to connect it over here. And this is not a good, let me make it more curvy. Okay, so this is concave up, hit 0. Okay, now the next point is 1. At 1, it's a maximum, and I'm going to be concave down. So concave up, I'm sorry, concave down and increasing. Okay, let's say it's over here. Then the next point I hit is 6, right? 6, between 1 and 6, it's decreasing and concave down. And we know at 6, it's going to approach negative infinity. So it's decreasing concave down and reaches negative infinity. Okay, that's good. Now, from 6 to 9, I'm going to be increasing and concave down. So I have to come up here, increasing, concave down, till I hit 9, which is a maximum, we said. And the next point we need to consider is 12. So from 9 to 12, I'm going to be decreasing and concave down. And keep in mind, as x approaches positive infinity, the limit is 0. So I'm concave down and decreasing. And at 12, I'm still decreasing but concave up. And it approaches 0. Okay. So this is my graph. Now, a couple things here. The derivative is 0 at the max and the min. Of course, this is not drawn perfectly, but you get the idea. So like this would be a maximum. The derivative is 0, maximum. This is a minimum. Okay. Now the other thing is that at 0, 6, and 12, these are the, well actually 0 is a point of inflection. So this should be kind of straight over here, like neither concave up nor concave down, so it'll be like kind of like a line. Same thing with, well, 6, obviously it's not defined there, so it doesn't make sense. And at 12, this is supposed to be kind of like a straight line with no concavity. Okay. So this is what my graph looks like.